All right, this is page 27. This is the free response number 1. One thing you might have noticed on the top, it says there's going to be 2 grades. It's going to be 1 rehearse grade, so don't freak out. I'm not going to count it twice. All right, let's go through it. So free response number 1, researchers studying a pack of gray wolves in North America collected data on the the length x in meters from nose to tip of tail, and the weight y in kilograms of the wolves. A scatter plot of weight versus length revealed a relationship between the two variables described as positive, linear, and strong. And so in this situation, we want to explain what is meant by each of the following words. I'll have you refer to the scoring guidelines for these ones. A positive relationship means that wolves with higher values of length tend to have higher weights. As something increases, the other increases. That's positive. Linear means that they kind of tend to fall somewhat in a line. So as a linear relationship means that as length increases by 1 meter, weight tends to change by a constant amount. Constant is linear. And strong means that they all kind of fall close to the line. A strong relationship means that the data points fall close to the line. And these are coming from the scoring guidelines from this free response, which I did share with you. All right, question 2. The data collected from the wolves were used to create a least squares regression line. Y hat equals negative 16.46 plus 35.02x. Interpret the meaning of the slope, which we have a template for. For every x unit increase, the predicted y variable increases or decreases by b units. Here's what the scoring guideline says. The slope of 35.02 indicates that 2 wolves that differ by 1 meter, so as the wolf length increases by 1 meter, in length, they're predicted to differ in weight by 35.02 kilograms, with the longer wolf having the greater weight, which honestly, I would just say, as the length of the wolves increases by 1 meter, the predicted weight increases by 35.02 kilograms. But this is what the scoring guideline had it worded as. Part C. 1 wolf in the pack with a length of 1.4 meters has a residual of negative 9.67 kilograms. What was the weight of the wolf? We also have a residual formula, y minus y hat. So the scoring guideline gets a little wordy. You know, I try to just kind of stick with the math here. So I would say I'd first get the predicted y hat, negative 16.46 plus 35.02 times 1.4, because that's your x value. Since we're given the residual, I have to work a little backwards. So I'm going to plug in negative 9.67 for the residual. Set that equal to y, since I'm trying to find the weight, minus my now predicted y hat. And I can add the 32.568, which you see down here. I mean, this is really the same thing. 32.568 plus negative 9.67 will give you 22.898 kilograms. So that would be your answer. All right. Thanks for watching.